Hello everyone, welcome back to Olsen Cafe. Today we are going to prove this trigo identity. So in this video, I will show you the basic fundamental you must know for any proving questions. So in this not so easy example, I'm going to use a very underrated thinking habit, right? A problem solving strategy to prove the identity, right? It is called Polya problem solving model. All right, so many of us, when we solve problems, we are already using Polya, right? Without even realizing it. So Polya problem solving strategies, there are basically 4 stages. So the first stage, right, which is understand the problem. So in this particular case, right, when we understand the problem, which means we need to know exactly what are the trigo function that we need. So over here, we get to see that we have sine 2x, right? We also have secant x and we have tangent x. So which means, right, you will need to understand exactly what are the trigo identities or properties that you will need to apply. And not only that, right, because this is a proving sum, right? So a proving sum, that means understanding a problem is also include, all right, that knowing that, all right, for proving, you must actually start from either the left-hand side and then you prove all the way till the end, right? Or you start from the right-hand side and then you go all the way prove to the left-hand side, right? So there is no way that you can work halfway through, all right, on each side and then prove that they are equal. All right, so proving, do take note that is only a one-way direction. So once you understand the problem, then we can move on to stage 2. Now, stage 2, all right, includes things like you must start to think of a plan. So what is this plan? So you will have to ask yourself, all right, the question, which is the side that is more complicated, right? Is it the left that is more complicated or is it the right-hand side that is more complicated? Right, so in this particular example, you will notice that both sides are equally complicated. So it doesn't really matter which side you would like to begin with. All right, so later on when I carry out the plan, all right, which is stage 3, all right, I will be showing you, all right, that I will be starting from the left-hand side. So at the end of the proving, right, then we will reach stage 4. So stage 4 is actually including the step whereby looking back. All right, so that means when you look back at your solution, always ask yourself, all right, is there a better way to solve or is there a more efficient method to prove the identity? So these are the 4 stages that we will be going through later on. So now that I have demonstrated how I have gone through stage 1 and stage 2, right, let us move on to stage 3, right, which is carrying out the plan. Alright, so as I mentioned earlier on, alright, I am going to start off with the left-hand side. So by looking at the left-hand side, right, I notice that I have sine 2x, which means I will need to apply double angle formula. Right, so if you are familiar with double angle formula, right, we know that sine 2x is equals to 2 sine x cosine x. Yeah, so I apply this identity and I also observe, all right, that I do have common factor over here. So beside 2, all right, I notice that cosine x are common, all right, in the numerator and it is also common in the denominator. So what I'm going to do is I'm going to factorize out the 2 cosine x. Alright, so this will give us 2 cosine x times 1 plus sine x at the numerator and 2 cosine x times 1 minus sine x, for the denominator. So what I can do here is I can simply cancel away 2 cosine x and this will give us 1 plus sine x divided by 1 minus sine x. Now at this stage, this is a part whereby a lot of students will get stuck. All right, they do not know what to do because they realize that 1 plus sine x and 1 minus sine x, there is no way, all right, for you to further simplify, all right, the expression. So at this point, what you can do is you can simply work out the right hand side and see what you will get, and then you're trying to sum it back and to see what you get. All right, but over here, I'm going to introduce to you one very useful strategy, all right, which means I am going to apply and take a look at the denominator. You can see it's 1 minus sine x. So this strategy is somewhat like for third, rationalizing the denominator. So if I'm going to use a conjugate cert, right? So if the sign here is minus, that means if I apply conjugate cert, that means the sign that I'm going to apply is a plus, isn't it? So I'm going to apply this as multiply exactly the same term for the denominator, except that I'm going to change the sign to plus. So that means I multiply the denominator by 1 plus sine x, and then the numerator by the same expression, which is 1 plus sine x. So by doing this, right, so you will notice that for the denominator, right, you will be able to apply the identity, all right, a minus b times a plus b gives you a squared minus b squared. So putting this together, right, I will be able to derive the denominator as 1 minus sine square x. All right, so the numerator, again, at this point, all right, there is no way for me to simplify, so I'm just going to leave it alone first. So let's take a look at 1 minus sine square x. Is there a trigo identity that you can apply and simplify over here? All right, so what I'm going to do is I'm going to simplify the denominator into cosine square x. All right, so if you are familiar, all right, then you will notice that I am actually applying this identity sine square plus cosine square equals to 1, right? Which means if I want 1 minus sine square x, all right, it simply means I move this to the right hand side. All right, so all I have is cosine square x. So therefore, I replace 1 minus sine square x into cosine square x. Now, so this part here, the next stage is simply just very much algebraic manipulation. So I'm just going to take out the square. And what I'm going to do is, because I can see there's fraction, right? So you observe that I can actually split the fraction into 2. All right, so by doing this, which means I will get 1 plus cosine x and then plus sine x divided by cosine x. Now, once I've done this, right, what do you notice? All right, because if you take a look at the question, right, I will need to rewrite it into tangent and secant. So are you able to see the correlation? All right, so if you know the identity well, you will know that 1 over cosine x is actually equals to our secant x. And sine x divided by cosine x is actually equals to tangent x. So which means I'm going to apply this property that I know. I'm going to rewrite this, and this will give us secant x plus tangent x. Yeah. So now what I'm going to do is I'm going to make it very explicit. Right? How am I going to rewrite this and to form the expression on the right hand side? So what I'm going to do is, because it started off with tangent on the left, right? So I'm going to just rearrange this and to rewrite, right? This will give me tangent x plus secant x. So this is basically the same. Now, so again, I'm going to just use algebra identity. So I know that a plus b bracket square, this is actually equals to a squared plus 2ab plus b squared, which means I'm going to expand this. So this will give us tangent square x plus 2 tangent x secant x and then plus secant square x. Isn't it? This is actually equals to our right hand side here. All right, so with this, I'm done and I proved the expression. All right, so of course, at this stage, once you are done, right, all right, we take a look at stage number 4 of Polya problem solving. All right, so that means we look back. All right, so when you look back at the whole entire question, are you able to actually start from the right hand side to prove all the way to the left? Right, actually, there is a way. Right, so you may want to actually give it a try and to see if you're able to. All right, so ultimately, it is really about what method it is more efficient, right, to you, and how much do you understand about the trigo identity. One important consideration that you must have, right, in proving question is that all the working must be very explicit, right? Even if it looks so direct and simple, you need to present all the details on how you derive each step of your presentation. So in today's problem, you notice I only applied one identity. Yeah, so over here I've given you the whole list, right, a summary of all the formulas that you need to know. Yeah, so to prepare yourself well, you must be equipped. So you need to know all these formulas well, right, and you must be able to apply them. So the only way, right, to know them and to apply them is to practice. The more you practice, the more you do, the more familiar you are, right, with the different strategies and the approaches, right? And in Polya stage number 4, right, it is always about looking back. All right, so look back is simply means, right, if there is a better way, right, a better efficient method to prove trigo identity. So to really do this segment of the trigo topic, there is no shortcut. The only shortcut, right, is to really know them well and to do all the questions. Hope you find this video useful. I will see you in my next video. Bye.